Okay, so now we're gonna do a little bit starting on circles. So let's go with a nice turquoisey color. Okay, so the set of all points equidistant from a point called the center is actually the definition of a circle. The set of all points equidistant from a point called the center. The center of your circle is named by a point. Here, if I put a little O here, this would be circle, and then it would be circle O. All right. The distance from the center to a point on the circle is going to be your radius. Okay. So if I have from O to, let's say, D, OD would be a radius. A segment whose endpoints are on the circle is a chord. So any segment whose endpoints are on the radius is a chord. A chord that passes through the center of a circle is called the diameter. So diameter is a special type of chord. We're going to call that CD is diameter. So as far as this drawing goes, AB is a chord, but also CD is a chord. Diameter is the longest chord. Okay, so I did this in a little bit of a funky order. So the next one is what's called a central angle. Is an angle whose vertex is on the center of the circle and whose sides are radii. So let's call this point R. So this angle right there, angle DOR, is a central angle. It's an angle that is at the center of the circle, the vertex. Also, angle COR is a central angle. So, all right, like I said, or like I've said all year, lots of vocabulary, the first unit. Okay, a line that intersects a circle in exactly one point is called a tangent line. Okay, thing with a tangent line, so like this, and we'll call this point F, and we'll call this point E. Much like me, it addresses a point and then goes off in a whole other direction, only touching the point once. So EF is a tangent line. Blank blank is a line that intersects a circle in exactly 2 points. So exactly 2 points is called a secant line. There is a relationship between the tangent line and the ratio, but it's a little bit much to explain even on a video. So a secant line would be here. So a secant line, all secants contain chords. So for this right here, G, H is my secant line. Okay, because it goes through the circle. So chords they have endpoints, they're segments. A secant line keeps going. So again, 2 points. So point of tangency. Okay, is the point at which a line is tangent. In this case, it would just be F there, would be our point of tangency. Okay, we have blank blank, an angle whose vertex is on the circle and whose sides are chords. Now, I don't know what you would call that. That is, so if I go across here to F, okay, so that would be this angle right here. This is an inscribed angle. I suppose I should have done that, like labeled each of them like this is a tangent line. Okay, this green one right here, this is a secant. This is a radius. This right here is a central angle. We have our diameter, and we have our chord, if you will. So that looks a little bit nicer, doesn't it? Okay, so now our last little set of vocabulary, this hasn't been too bad, is the set of all points between and including any 2 points on a circle. So that is actually going to be what's called an arc. So here, draw some points. Here, and then we're going to have a point here. So we're going to say this is I, this is J, and this is K. So I to J, this is an arc. When you write an arc, you're going to put a little arc over it. So put an arc. Okay, because otherwise, if you just write IJ, that would actually be the distance from I to J, which would be right there, which is not what we are looking for. So, you have different types of arcs. So arc over here is an arc that measures less than 180 degrees, is called a minor arc. Okay, so IJ here, this is a minor arc. Also, JK is also a minor arc. So less than 180 degrees. So we have IJ and we have JK. Next type of arc is an arc that measures greater than 180 and less than 360, which is called a major arc. So a major arc, I just have to make 1 point, is if we are talking about, let's say, this arc right here. Actually, I don't know how I want to draw that. So if I'm going from here and I'm going all the way around the inside, all the way to here. So it starts there and goes there. This would be your major arc going all the way around. There we go. Okay, the major arc going all the way around. The thing with a major arc is it has to be named. Has to be named by 3 points. Okay, so if I were naming that blue arc that I just drew, I would name it JIK or KIJ. Okay, I put an arc over it. This would be the first one. The first point is an endpoint. This is an endpoint. And this is going to be a point in the middle. It has to be named by 3 points. Otherwise, if I said JK, I would actually be naming this minor arc here. So just be careful with that. All right, and last but not least for this vocabulary is a semicircle. Sorry, I wrote an arc that measures exactly 180 degrees. So if we're talking about a semicircle, it would be from I to K. You could either name it IK or you could name it IJK. Doesn't really matter too much. I could also name that KI, named by the endpoints of the diameter. Okay. Yeah, and then direction doesn't matter actually with a semicircle. So, all right, so that's the super boring vocabulary. I want you guys to, if you're watching the video, I want you to stop taking notes. Try these on your own. So stop the video. Okay, do fill in below. I'm going to keep going, but hopefully you paused. Okay. So you can use the diagram below with a bang to classify each part. Parts may be used more than once. So first thing is LQ. LQ, it just intersects a circle in 1 point, so this is going to be a tangent. And you can write just tangent, you don't have to write tangent line. Angle or segment WY, endpoints are on the circle, so this is a chord. Angle NQR, so NQR. If it's on the circle, if the vertex is on the circle like it is here, NQR, then that's going to be an inscribed angle. Okay. Point X is, of course, the center of our circle. Arc RWU. So arc R to W to U, all the way around to U, that's going to be a major arc. Okay, line ST is a point of tangency. Actually, why do I do line? Oh, it's just a tangent. Just said point of tangency. It's a tangent because it only intersects each circle in 1 point. PN is a radius. Angle UXY comes from the center of, it's an angle that comes from the center, so it's a central angle. MQ, it's an arc that is less than 180 degrees, so that is a minor arc. QN is a diameter. Point R is a point of tangency. UY, that's a secant because it goes through the circle. QRN, if you do QRN, well, QN is a diameter, so therefore this must be a semicircle. MPQ, P is the center of a circle, so that's going to be a central angle. Okay, QR is going to be a chord. UYR is an inscribed angle. WY is a minor arc. Segment LN, that is a secant because it goes outside the circle and intersects the circle in more than one point, so that is a secant. UX is a radius. R to U to Y, so R to U to Y, that is a semicircle. So make sure, then check your work. Hopefully that went well. Alrighty. So let's go to the rest of this, just a couple pages. So, arc measure. So I want to talk about arc measure. The measure of an arc formed by the endpoints of the arc. It is measured in degrees or radians. Okay. And it is, well, we'll talk about central angle in a minute. Okay. So what you'll notice is when you have arc AC, this is the measure of, so when you're talking about the measure of, you always put an M on the outside like that. So the measure of arc AC, so the measure of an arc is equal to the measure of the central angle. So we're going to talk about that in a minute, but arc AC is 84 degrees. Okay, that's what my intention was with that, but then put that in the wrong spot. Okay, and then the measure of arc ADC is going to be 360 minus 84, which is 276 degrees. Oh, apparently we need to change. Okay, so looking at this, you see that your little congruent symbols. When I look at a problem like this, I try to find all of my missing arcs. So like EF is going to be just 180 minus 53 minus 34, which is 93 degrees. And then I want to find these three arcs. They're all congruent to each other, so that's going to be 180 divided by 3, which is 60 degrees each. So the measure of arc AC, say AC, CE, there we go. CE is just going to be your 53 degrees plus your 34 degrees, which is equal to 87 degrees. Okay. The measure of arc EF, so from E to F, that's the 93 degrees. The measure of arc E to C to K is going to be the 34 plus 53 plus 60 plus 60, which is 207 degrees. And angle arc DFC, so D to F. So from D to F all the way around to C, instead of adding all those angles up, I'm just going to do 360 minus 53, which is 307 degrees. Okay, so our next thing is a central angle. A central angle is an angle whose vertex is the center and whose sides are radii. Okay, like this guy right here. So angle ABC. Now, the measure of a central angle is equal to the measure of its intercepted arc. One little piece of vocabulary missing is an intercepted arc. Is an arc that has endpoints that intercept a circle. That are on the sides. Not doing a great job with the descriptor of that. So for this angle right here, angle AC, this is the intercepted arc, okay, of angle ABC. No, so by definition, the measure of angle ABC is going to be equal to the measure of arc AC. So you can find arc measure from the central angle. All right, which is what it says here. I don't even think you need this intercepted arc thing. Get rid of that. If you wrote it already, that's great. So this right here. There we are. Okay, so for this circle right here, there are things that we kind of make a note of. If this is 39 degrees, this one right here is 39 degrees, which means this arc is 39 degrees, this arc is 39 degrees. This is going to be 180 minus 39, which is equal to 141 degrees. And this one here is just going to be your 180 minus 70 minus 39. Okay, which is 71 degrees. And like I said, I like to find all of those before. So this asks you to find the measure of arc AC, which is equal to your 39 degrees because they were congruent to each other. Angle KBD is equal to 39 degrees because the intercepted arc. The measure of arc EK is going to be this one right here, which is 71 degrees. The measure of angle EBK is also going to be 71, or KBD. EBK is also 71 degrees. So again, make sure intercepted arc and central angles are the same. So for these, just take a minute, try on your own. Okay. I'm going to do the big giveaway for answers. Okay. So this angle and arc right here are 21 degrees because we subtract from 180. these are the same, and so this is 72 degrees, which means that this arc right here and angle must be 108 degrees. So UXV is 72 degrees. The measure of arc ST is 21 degrees. The measure of arc WV is 108 degrees. The measure of arc TW is 93 degrees. And the measure of arc TVW is going to be 360 minus 93, which is 267 degrees. Because sometimes it's easier to subtract. Then we'll just do a little algebra problem here. So we know that this is 90. We know that if this is 90, I know that all of these angles add to 360. So look for things like vertical angles, but in this case, the whole circle is 360. So it's going to be 8x plus 10x plus 9 plus 21x minus 12 plus 90 is equal to 360. Then we combine our like terms, our 8, our 18, and our 21. Is 47x, and then we take our 9, subtract 12, and add 90, is plus 87 is equal to 360, subtract 87, is 273, divide by 47, okay, I think I did something wrong, 8, oh, I wrote 18, this is a 10, there we go, let me fix that, I had a feeling. It's 39x. So this should have been a. Sorry about that, guys. There we go, and x is equal to 7, because these usually come out very nice, and this one just did not. Okay, knowing x is 7, 8 times 7 is 56. 21 times 7 minus 12 is 135 degrees, and then 10 times 7 plus 9 is 79 degrees. So XW is 135 degrees, YW is 146 degrees, YX is equal to 79 degrees, and then VXW is going to be, and we could do 360 minus 146. Is 214 degrees. So that's that. All right, so last thing that we're going to talk about is arc length. So arc length is a little different than arc measure. So first up, we're going to go through our definitions here. So the distance around a circle is your circumference. Okay, we have a couple formulas for that. Before we get to that, the next thing is the ratio of the circumference to the diameter of a circle is actually pi. So pi is equal to the ratio of the circumference to the diameter. Like when you divide the circumference by the diameter, you get pi. So if I multiply each side by diameter, I end up with circumference is equal to pi times diameter, which happens to be our formula for circumference of a circle. Okay, so that's where that comes from. All right, actually I'll do a little arrow up here. I also know that the diameter is equal to 2 radiuses, so this is also 2 pi r. Okay, so, oh, there is no circle here. Well, that's interesting. It did not show up. So we're going to imagine that Miss Holly can draw a good circle with her iPad. And if I give you, let's say the radius is 12 inches, it does not tell you to round, so my circumference is going to be 2 times pi times 12. So my circumference is going to be 24 pi inches. And this is, when I write it, this is in terms of pi. So there is no rounding here. It says find the radius of a circle with a circumference of 35 pi yards. So I know circumference is equal to pi times diameter. 35 pi is equal to 2 pi times my radius. I divide each side by 2 pi. The pi's divide out. I end up with 17.5 is equal to r, or 35 halves, and this is going to be yards is equal to r. Okay, and then the last one says find the diameter of a circle with a circumference of 65.97 meters. Okay, so I know circumference is equal to pi times diameter. So I know 65.97 is equal to pi times diameter. So I divide each part by pi. So my diameter is equal to 65.97 over pi. This would be your exact answer if you divide it out by pi. And do not use 3.14. You're going to use the pi button on your calculator. Pi button on the calculator is below clear and below the arrows if you're using a TI. But, all right, and so my diameter is going to be 21.00. I'm just paying attention to this right here, which is that's rounded to 2 figures, meters. Okay, so this is exact and this is approximate. Because anytime you have to round, your answer is approximate. Okay, last concept for today. So once you have circumference, diameter down, what we're going to talk about is arc length. So the measurement of a portion of the circumference of a circle. So that is what arc length is. So basically, you have your arc measure, which is just basically like how big your opening is on your circle. Arc length is if I took a ruler or a measuring tape and measured along here, like how many inches or feet. So with arc measure, the circle could be small or it could be large, but it can have the same arc measure. Like 180 degrees on a very small circle, that's going to have the same arc measure on a very large circle. But the length of the arc, like if you actually took a measuring tape on it, is going to be a little bit different. So you have a couple of different formulas that you can learn for this, okay, because it is a portion of the arc. Before we get to that though, so for the diagram below, the distance from A to C is equal to 4. It says find the circumference of the circle, of circle A. Hopefully that says it on yours. So first off, if I know that the radius is 4, then I know my circumference is going to be 2 pi times my radius is 4. So I know my circumference is going to be 8 pi, whatever units there are. The measure of arc CBD, well, what's the length or the measure of arc CBD is equal to 180 degrees because the endpoints are on the diameter. The length of arc CBD is actually going to be 1/2 of your circumference because this is the portion of a circle. This is 180 degrees over 360. That's where that came from. Okay. It's going to be half of 8 pi. So the length of CBD is going to be 4 pi. Arc CBD. And we don't write that as measure of. We actually just write it out as length of CBD is going to be 4 pi whatever units. So there are two little formulas for my diagram here. I have measure of my central angle over 360. So part over whole is equal to arc length is equal to the length of the arc over C, which is your circumference, which is your part over whole equals, so it's part in degrees over whole in degrees equals part of the circle over the whole circle, which is one way to look at it. The other formula, which is probably going to be a little bit easier, especially now, is so to find the length of the arc, you're going to do whatever the measure of your angle is, so the central angle, over 360 times your circumference, okay, which is either 2 pi r or pi times diameter, is equal to the length of your arc, okay? And that just depends on what you're given. So for example 9, it says find the length of the arc indicated. So I want to find the length of my arc. I know that the measure of the arc is 135 degrees over 360. And I know that my circumference is going to be 2 times pi times 16. So the length of my arc is going to be 135 over 360 times 32 pi. And you guys can multiply across and simplify. Okay, so you can do, you can cross simplify if you want. I think it'd just be easier to do 135 times 32. So that's going to be my length is equal to 4320 over 360 times pi. But we want to simplify that. I know the zeros would simplify out. I know 432 I can divide by 2 is 216 over 18 pi. I know that can be simplified to be 108 over 9. And here's your life lesson because you first should see if that's divisible. So I was trying to simplify like a fraction, but for this, 4320 over 360 actually goes in evenly. This is going to be 12 pi meters. Okay, so example 10, and then this is a big or. I think this is going to be less confusing. So find the radius of circle as an arc measure of 270 degrees. So we know the measure of the arc is 270 over 360. We don't know what the radius is, so we're going to do 2 pi r is equal to, and I know the length of the arc is 18 inches, so we're going to go through and multiply this out. So this is 540 over 360 pi times r is equal to 18. I'm going to multiply by the reciprocal, which is 360 over 540 pi. Multiply this by 360 over 540 pi. So my radius is going to be 18 times 360 is 6480 over 540 pi, which when I divide it out, my radius is equal to 12 over pi. Wait, is this 18 pi inches? It is 18 pi inches. I'm so sorry, guys. This is what happens. So if this is pi, this is going to be pi, this is pi, and the nice thing here is that these pi's divide out. Okay. And so you're left with your radius is 12 inches. Okay. Next thing, find the circumference of a circle. Okay, so just try and find the circumference. If the length of an arc that in a circle contains 36 degrees is 2 centimeters. So I know my angle is 36 over 360. I don't know what my circumference is, and I'm finding the whole thing. But I do know that the length of the arc is 2 centimeters. Now this one does not have pi in it. This one's a little bit tricky. You can simplify beforehand. 36 over 360 is actually 1 over 10. It's equal to 2. And then I multiply each side by 10 over 1. And my circumference must be 20 centimeters. So that one wasn't too bad. I didn't have any math equations that weren't appearing, which makes this a little bit more challenging. In a circle whose circumference is 18 centimeters, find the measure of the central angle of an arc whose length is 6 centimeters. So in a circle whose circumference is 18 centimeters, so I know my circumference is 18. I don't know what the measure of my central angle is. I know that that's going to be over 360, but I do know that the arc length is 6 centimeters. So I can write this as going to be 18x over 360 is equal to 6. I multiply by 360 over 18. 360 over 18. X is equal to 6. 360 over 18 is 20. 6 times 20 is 120. So, and that's 120 degrees. And I think, I know you guys have been following on, but I'm actually just going to get rid of this formula right here. We just don't need this. Okay. And so there you go. That's how you do it. So arc measure is just the angle. You can just look at it. Arc length is a little bit different. It's a little bit more complicated. Hopefully this was helpful. And hopefully you fast forward through what you needed to. So have a good day.